Okay, so I start this module with a quick kind of overview of georeferencing. You can see my subtitle, Putting Rasters in Their Place. Sort of a play on words there, but essentially what we're talking about is taking some sort of a scan map or image that we're going to have to put into some coordinate system that will be able to make that data overlay with our other GIS data. So we're kind of literally putting them in their place. So what I want to do is give you a brief overview here of some rules of thumb and some other things regarding georeferencing, but I also wanted to give you a quick tour of what you can expect to see with regard to the next video or videos and the demo. So if I just open up my Windows Explorer here, you're going to see that I have a JPEG in here called Codorus. That's Codorus State Park, just over the line in southern Pennsylvania, just on the other side from the Maryland-Pennsylvania border. And then I have a national parks map. There's national parks across the country. Both of them are not super high quality maps, but they're good enough for demonstration purposes. This is my georeferencing demo MXD, which I'm going to open up here in just a second. And then you can see that I have a shapefile here of states. It's just a vector file, a shapefile of states that I'm going to use to show how to georeference the national parks map to these states. While we do the georeferencing of Codorus State Park, I'm actually going to be using ArcGIS Online data. And the reason why I like to use the states for the national parks map is because it's an example of how we can georeference using local data rather than data that's online through ArcGIS Online. Depending on how fast your internet connection, it could spin a little slower, but I did want to show the advantages of both. So a quick tour of kind of what we have coming here within the context of these next couple of demos. So just a couple of rules of thumb, and honestly these are going to make more sense when you see me interacting with the demo in the next video, but I just wanted to get them across because these are things that I'm going to refer to as I go through the demonstration. So the first one is to add your reference data to your empty data frame first. So if you're going to use ArcGIS Online data, you're going to want to add that to an empty map first. And as I say here in the second bullet, it will accept the coordinate system of the reference data. I did want to point out that ArcGIS Online, you may want to make note of this, uses Web Mercator Auxiliary Sphere. Web Mercator Auxiliary Sphere. Again, that is sort of a standard that Esri has used to push out its ArcGIS Online data. It is a defined coordinate system and projection that will then project your data onto it. So just be mindful that if you're georeferencing to that data, that is the projection coordinate system information that is being attached to your data or your raster once you georeference it to it. Turn off auto adjust. You'll understand what this means when we look at the georeferencing tool in the demo, but it's one thing that you don't want your raster jumping around on you while you're trying to set your control points. And so what I typically do, it's a good practice to just turn off auto adjust, set up all of your control links, and then turn it back on when you're ready for your raster to move. And again, that's going to make more sense to you when you actually see the demonstration video. Speaking of control points, or what are sometimes called links, my rule of thumb is green means go and red means stop. So just like a stoplight, you're going to set up control points in a raster, and you're telling that part of the raster to move to where you tell it to go. And so in ArcGIS, when you use the control point or links tool, you're setting up places in your raster that are going to move to either your vector data or your other raster data or your ArcGIS Online data. Again, referring back to your reference data that is in a known coordinate system that you are then taking your raster and transforming it into. So when you set up your control links, what is going to move is going to be a green cross, and where it's going to stop, where you click in the interface, is going to be a red cross. So green means go, red means stop. You'll hear me say that again in the demonstration video. And then the last sort of rule of thumb, when possible, start in the upper left-hand corner and work clockwise. You can imagine a rectangle or square-shaped map that you're trying to move and put into coordinate space, for example, from image space, as I'll call it. When you scan a map originally, it's sort of floating out there. It doesn't have any coordinate system to it. And that's the point of georeferencing here. We're putting it into a known coordinate system. I like to set my control points starting in the upper left-hand corner and working around in a clockwise fashion. And if I need to set up some links in the middle of the map, I do so. So again, some things that are going to make more sense to you as we go throughout. But when you practice this on your own, I'd like to make sure that you guys have the PDF of this overview open and available so you can kind of follow what I'm saying here. couple more things about georeferencing. World files. The raster file, in this case, I'll bring that up here in just a second. The Codorus JPEG image, you can see that we're using a JPEG, and the National Parks map is also a JPEG image. When you complete your georeferencing activity or process, it writes out another file that accompanies each one of your rasters. So you'll see a Codorus.jgw or a nationalparks.jgw file. And as I go back into the lecture here, or this PowerPoint slides, the key here is the W. So, for example, our Codorus State Park and our National Parks map are JPEGs, and when you update your georeferencing, which you'll see in the demo, it will write out a new world file that basically tells the raster where it's registered in the world or where it is in the world. If you lose that file at some point, but you retain the JPEG or the TIFF, you still have the actual original raster, but you've lost the coordinate system information, and that raster is no longer located where you georeferenced it in the world. Again, this will make more sense when we get into the demo video. One of the things you're going to have to be concerned with when you're doing georeferencing is what's called the RMS error, or the root mean square error. I pulled this quote from the A to Z Guide. It is an optional book for this course, so some of you may or may not have gotten it. But the Illustrated Dictionary of Geographic Information Systems, page 182, talks about the root mean square error, or the RMS, being a statistical measure of the difference between locations that are known, like in your reference data, and locations that have been interpolated or digitized, basically where you have told your raster to move to. So that RMS error is going to be a calculation that ArcGIS does for you that you're going to have to consult, and the lower that number is, the better the registration is, but it's definitely not a complete, comprehensive indicator of how well you've matched your data up to the reference data. So that's going to be important as you move through the process of georeferencing. And then the last thing I want to talk about here are what we know as transformations. Basically, what I like to call the icky math, or basically the math that gets done that allows for the movement of the raster to its coordinate space. So what I'd like for you guys to do as part of the process of experiencing georeferencing before you actually do it for the first project is to go to the ArcGIS desktop help within ArcGIS and search for georeferencing. It's going to pull up several topics. The one that I want you to select is going to be fundamentals for georeferencing a raster dataset, and that help page, if you will discuss what we mean by first order, second order, third order polynomial, and then the adjust and spline methods, which are more for local type maps. But basically what it gets down to is this is the mathematical computation that the software does for you to take your raster and stretch it and warp it and twist it and put it into the place and space that you're indicating with regard to your reference data. So I'll refer to this in the demo with when talking about first order, second order, and third order polynomials. The higher order the polynomial, as I mentioned here in the last bullet, the more stretching and warping and bending you can do to your map. And so we'll see how, as we place control points in our map, or on our map, how those different orders of polynomials will come into play. So things to think about, items that you're going to hear me talk about in the coming demo, but again, nothing really that might make much sense to you with the exception of a couple things. But as we go through and get to know the georeferencing tool and then actually do some georeferencing, all of this will make a lot more sense. So what I'd like for you to do is move on into the georeferencing tool demo, and you can get a run through of the tool itself, and then we'll move into actually georeferencing some rasters.